to bring a linear system with three equations in this form. And this is what we do now as an example, and then later we will just simplify this method using the matrices notation. Okay, so this is what we are going to do in this method that is called Gauss method or Gauss elimination method. This form here, this form, it's an upper triangle. So as you see here, you are just bringing this system in this upper triangle form, or triangular form. And also it's referred to as echelon form. Okay. So once we bring a system in this echelon form, this means that we can easily substitute back bottom up to evaluate the other variables. Now, this method is called also Gauss elimination method, and we will solve an example here and see how to work with this method. So maybe this example is let me just write the example, and then I will be giving you some hint. So negative 3x plus 2y minus 6z equals 6. So this is the first equation. Second equation is 5x plus 7y minus 5z is also equal to 6. And then the last equation is x plus 4y minus 2z is equal to 8. Okay, so of course the task here is telling me solve the system, the linear system. And again, solve means find the values of x, y, and z that verify this system, or for this for these values the system is logically true. Okay, before we start with this, we agreed on the notation, and in each step we will be thinking systematically. So here maybe to start with, you might assume that there is something like a diagonal here, and I just want to bring it in this diagonal form. So maybe something like that. Okay, so meaning here that systematically in each step you will be eliminating one of these circled elements using the row operations. Okay, how to do this? You will be starting from by eliminating one of these. But a very important note here, actually two notes. The first one is that there is no way to do it. There is no one way to do it. Okay, there is no recipe, patent recipe that will tell you you have to start with this or that. But it's good that you start systematically. So in each step you will just say, okay, I will, in this step I will be eliminating this one, meaning bringing it to 0. And very important that you will be having calculations. So you will be involving here another row and multiplying and adding and subtracting. And you can, believe me, you can easily do very simple arithmetic errors if you try to do it, you know, just orally without writing. So that's why I urge you to get a piece of scratch paper ready and do the steps on this paper. So I'm going to get the paper here and we will do it here. I will be doing this in green here on this paper so that we make sure that we don't make any miscalculations. So this is an important actually advice here, that I think that human beings usually tend to jump quickly to conclusions, but in mathematics you have it's no problem if you go an extra mile just to make sure that things are going the right way and you are making the right calculations. Okay, now let's start with the first step, which is eliminating one of the circled values there or terms. So what I'm going to do here is I'm going to eliminate this. Okay, now here don't worry, since we can be swapping we can be swapping the rows and columns. It doesn't matter if we have this one here up or there. At the end we will arrange it. So what I'm going to do, I'm going to eliminate this 3x in the first step. Okay, to do this, if you look at these three equations, of course, by default, this is R1, this is R2, and this is, let me just label them, R1, R2, and R3. Now, to make this 0, what do I need to do? I think you all figure out that I can, the easiest thing, if I multiply the third row with 3 and add them up, okay? And replace the first row with the result. Okay, so I will be just, as we agreed, I will be just writing this step in on top of this arrow. What's the problem with this pen? Okay, so here I'm going to replace R1, row 1 will be replaced with 3R3 plus R1. I hope this notation makes sense to everyone. Are you fine with this notation? Okay, this step, I'm going to replace the first row with 3 times R3 plus R1, because if I have 3 here, I add it up here, it will just cancel out. Okay, what do I get here? Sorry. Okay, then let me just put this whole system here in this notation. Let's leave the first row here. Second row remains the same, 5x plus 7y minus 5z is equal to 6. The third row also remains the same. Notice that I'm using the third row, but it's not changing. I'm just changing one row at a time, which is the first row. Now here, what is the result of this? As I told you, let's go back to the scratch paper here, and then I will be just writing the first row, minus 3x plus 2y minus 6z equals to 6. So this is the first row. And 3 times the third row we said is 3x, 4 times 3, 12, minus 6z equals to 24. Is it 24? Okay, if I add them up, this will cancel out. I have 14y minus 12z equal to 30. Okay, so this is the new R1 that I'm going to replace here. Okay, so here I go to row 1. Of course, here I have 0, can write it, 0 plus 14y minus 12z equals to 30. Notice that here I just multiply all the row, even the constant here to the right. Okay, so this is the first step. Now, the second step, I want to just make sure that I simplify as much as possible. So this step is very simply, I'm just dividing this by this row by 2. This is all. So I don't like to work with large numbers, and since you can divide it by 2, so it's just 1/2 of R1. So if you like, so here what will I get is the following. No need to write it here on scratch paper. So here I get 7y, I get here 6z, and here I get 15. The other rows remain the same. And then I have here minus 5z, this is equal to 6. Here I have x plus 4y minus 2z equals to 8. So this step is just divided the first row by 2 or multiplying by 1/2. Now I will try to get rid of this 5x here, okay? Get rid of this 5x. What to do here is I will multiply this row here with minus 5, so R2 will be replaced by minus 5R3, and I will add to it R2. Okay, so I will multiply this with minus 5 to get rid of this 5 here, and then see what I get. Okay, I hope that. Please ask questions if something is not clear. So I will be doing this again on the scratch paper here. So I hope you can see it here. So I have the second row is 5x plus 7y minus 5z equals to 6. And then here I multiply directly by negative 5. So I have negative 5x, negative 20y, positive 10z, and here I have 40, negative 40. Okay, so this will cancel out. So here I have negative 13y, and here I have minus becomes positive 5z, and here I have 34, negative 34. Okay, so this is what I'm going to replace. The second row, first row, third row remains the same. Okay, so this is after applying this 0 plus 7y minus 6z equals to 15. And then here I leave this x plus 4y minus 2z equals 8. So here we said it's negative 13. 0 minus 13y plus 5z equals negative 34. Okay, now the next step here, I'm just going to just simplify this one. You see here, if you have here you have 13. If you multiply this with 2, you'll be getting 14. So you will be getting something. So in this step, I'm just simplifying rather than eliminating anything. It's just simplifying to get rid of this 13. Maybe you can just replace R2 by twice R1 plus R2. So because here you get 14, 13, then you will have it in 1. I don't like to work with large coefficients of the. So let's do it also on the scratch paper, this step. So what do we have here? 2R1 is 14y minus 12z equals to 30. And R2 is negative 13y plus 5, sorry, plus 5z is equal to negative 34. So if you cancel this, you will be getting y. Here you will be getting 7z and this is negative 7z, and here you get negative 30. No, negative 4. Negative 4, because you subtract 30 from negative 34, okay? So in this step, I got the following. Okay, first row remains the same, so 0 plus 7y minus 6z equals 15. Now the second row becomes, we said y plus y minus 7z. And then here I have minus 4. So this is the step I carried out, x plus 4y minus 2z equals to 8. Okay. Now the next step is to get rid of this 7 to get rid of this 7y here. So obviously here I need to multiply the second row. So the first row here, it will be replaced by minus 7R2 plus R1. Because here if I multiply with minus 7, I will be having plus 7 here, and it will simply cancel. Okay. So let's see if I do it here again on the scratch paper, what do I get? So I have here row 1 is 7y minus 6z equals to 15. Second row multiplied by negative 7, it will become negative 7y, negative 42, right? Oh, hold on, is it 6 or 7 there? Okay, so negative. So here I have 7 times 7, 49. 49, negative 49. 49, and here I have 7, negative 20, 23. But if I multiply it with, no, it's positive 28. Yeah? 4 times 7 is 28. Okay, so if I simplify it here, I have negative. Is it positive or negative, this one here? You see, it's a little bit sensitive calculation here. So here you have 43 also. You have minus, and this becomes positive because you multiply with negative. So you have positive 43z, and here you have 43. Okay, so Okay, so here you have 43. So in this step, I simplified the first row to 0 plus 0 plus 43z equals to 43. Second row is 0 plus y minus 7z equals negative 4. Third row, x plus 4y minus 2z equals to 8. Okay, I'm done actually. I'm done, but I can do here one more step. I can just, this one, I can just divide by 43. So I will be getting R1 is now Z equals 1. And the rest remains the same. So here I have 0 plus 0 plus y minus 7z equals negative 4. And the last one, x plus 4y minus 2z equals to 8. Now here you see it's almost in a triangular form, but it's upside down. So I need to just flip some rows. So I bring this one down here and this one up, and it's done. Okay, so this is all. Let's do it on this page. So I flip R1 and R3. So here this becomes first row, 4y minus 2z equals to 8. And here I have y minus 7z equals to negative 4. And this last one is just c equals to 1. So as you see here, we managed actually that was our goal, to get this into a nice upper triangular form. And we can just solve it. We know z here. If we plug it in here, what do we get? So we get y equals, let's say, minus 4 plus 7z. And this is equal to 3, right? Is it correct? You have 4 negative plus 7 is 3. Okay. And from here we have z equals to 1. So this is the first one. And then if I plug it here, I will be also getting x equals 8 minus 4y plus 2z. And this is equal 10 minus 12, right? And 10 minus 12 is negative 2. Negative 2. Okay, so x equals negative 2, y equals 3, and 1 are the solution. Yeah. Here you have to plug it in. Okay, any questions regarding this one? Questions? It couldn't be that you don't have questions. Is it that simple or positive? What is positive? Abdul Rahman, what is positive? Is it question or what you are referring to? Okay. All right. So solving systems of linear equation, in particular here, what we demonstrated is third order, is to try to bring it in this form. So again, here I will just remind you about the two very important advices I mentioned before we started with this solution of this exercise. The first thing is that here there is no one way to solve it. So here, as you see, for instance, here, maybe at this stage here, you can multiply this with 5 and this with 3 and cancel. For instance, you can, instead of using this one, you can start with different steps, but ultimately you will be getting to the same result if you just are doing the right steps, the logical steps, then you will be getting to the same final result. Okay. So there is no patent recipe for that, number one. Number two is we have we are working even sometimes with very basic steps. I don't know what was the term for this in English, but in German they say Kopfrechnen. That means you just calculate it in your mind without using paper or. And this is here. It can lead to very simple errors, arithmetic errors. So that's why keep a scratch paper on the side and try to just verify each step using the scratch paper. And then, as we did it, bring it to the right position so you to make sure that the calculations are performed exactly. Sometimes a negative multiplied with a negative or whatever, if you just do it without scratch paper, you might be getting an error. Okay, so this is regarding this method. Now, and I told you this is referred to as Gauss elimination method. Now, as you see here, we can continue with reduction here. So we had z equals to 1. We can continue, for instance, by eliminating this z here, this y, and this z, and only leave the diagonal. So we continue with eliminating the upper triangular part, and then you will be ending up with a diagonal. If this diagonal is non-zero, then you multiply by the reciprocal, you will be getting this one. This method, if you reduce it further to get this, is called the Gauss-Jordan elimination method. Okay, so here just to Gaussian elimination method, you reduce to the so-called echelon form, which is an upper triangular form. But as you saw in the previous example here, we got it in this upper triangular form, but then to find out the final answer, then you need to make calculations. Okay, you need to make calculations. So from down to upwards to evaluate the values for y and x in this case. But if you go all the way and reduce it to what we call the Gauss-Jordan elimination method, then you end up of having here x, y, z, and here you have something equal. In this exercise, you will be having what was the solution there, -2, and here I got 3 and 1. Okay, so that means here you will be reducing this to the coefficients of there is 0, which is the identity. Okay, and this method will lead to something that we call reduced echelon form. Reduced echelon form, or sometimes it's called echelon reduced form. So it's reduced echelon form. However, this one, the upper triangular, is a reduced, is not reduced, it's just an upper triangular form. Okay, any questions regarding this? Questions? All right, so let's go to the next topic. Now, we said that we might get linear systems with let's go back to our example, to our previous example. Okay, we said that sometimes in the case where we have no solution, this method, this elimination method, will result in what we call a contradiction. Contradiction means it is something illogical. You might be ending up of having a number is equal to a different number, which is no value of x on y and z will satisfy this. This is what we call a contradiction. Let's see an example. Let's see an example of where you get no solution. Okay, if you have the following linear system, okay, so 1x plus, let's say here, z is equal to 1. Then you have x plus y plus z equals to 2. And then you have x plus y plus z equals to 1. Okay? So this is the example, and it's asking you solve this linear system. Now, of course, we can apply we can subtract any of the rows. Let's say here I'm going to add row 1 and row 2, or subtract row 2 minus row 1. Okay, row 2 I subtracted minus row 1. Let's see what we get. So the first one here, it remains the same. The first row, you have x plus z equals to 1. Then here, what do I get? 0. Then I got here y. Here z minus z is another 0. And this is equal to 1, right? Yeah. Sorry, this one is minus, not plus anyway. This one of these is negative, not positive. Both are positive. The last one here is negative. Last one here is negative. Okay. So x minus y plus z equals to 1. Okay, now in the next step, I can subtract R3 from R1, see what I will get. R3, replace it with R3 plus R3 minus R1. So R3, so first one is the same. Okay, second one is the same, 0 plus y plus 0 equals to 1. So here, of course, you have 0. Then what we get, R3 minus R1, R3 minus R1. We got 0 minus y, and c minus z is 0, and this is equal to 0. Now, if we add R3 and R2, you see here we have y and negative y. So R3 plus R2, we just do it on this page. So you have here x plus z equals 1, y equals to 1. And here what we got? We get here y minus y plus y is 0, minus y plus y. And here I got 1 plus 0 is 1. You see, this is the contradiction here. This is the contradiction. Once you reach such contradiction in your elimination, this means here there is no solution. There is no solution because ultimately we are deadlocked here. Yeah, we have two numbers that are not equal to each other, and we set them equal here to each other. So this is the definitely not possible to find any number that satisfies that. So in this case, you need to stop here, and then the conclusion is there is no solution, or at least no real solution for this one. Now, let me do something else, and then I will show you a very good attitude while working with linear systems. If we have a linear system, let's assume we have this linear system. So later in the second lecture today, we will introduce matrices and we will work on matrix operations. But for now, just keep in mind the following. A linear system, we can write a linear system in a matrix form. Let me just give you an example here. So the linear system is given x plus 2y plus 2z equals to 4, x plus 3y plus 3z equals to 5, and here last one is 2x plus 6y equals plus 5z is equal to 6. Very simple step here, but we will see later it will be the start of evaluating the systematic Gaussian elimination. Now, here by default, if you have only x, you have only 1. I will take the coefficients of the variables and make sure that you have here x, y, and z all in one column, 2, 3, 6, 2, 3, 5. And make what I call the coefficients matrix. Let me call it A. I will take this column here and I will just call it B. Okay, B, the right-hand side of the equation, right side of the equation. And I will take another, notice that this right side, it is a vector. It's one column vector. I will take another vector, which is the variables, and I just vector, and I will call it capital X. This capital X will include the X, Y, and Z variables. Okay. And I will put these in the form AX equals to B. This is what we call the matrix form of the equation of the linear system. So for this particular example, I hope it's a simple step that everyone can find out that this is the matrix containing the coefficients of the variables, only the left-hand side, 1, 3, 3, and then I have here 2, 6, and 5. This is my A. I multiply this with capital X. Now, capital X includes small x, small y, small z, if you like the variables. And notice that solving, meaning I find the values of these. I will find the vector x, y, and z that will satisfy this. And the right-hand side is just the matrix or the vector, because a one-column vector is a matrix. Okay, this is what I call the matrix representation of the vector of the linear system. Now here a very important note here that I will just show you. First of all, this is matrix A, right? This is matrix A. And this matrix the system has a non-trivial solution if and only if the determinant of this matrix is not equal to 0. That means in the previous example, let me show you, where is it, the previous example here. Yeah, in this previous example, we didn't get a solution. If you consider the matrix for this one, so it will be 1, 0, 1, 1, 1, 1, 1, minus 1, and 1. Anyone can evaluate this determinant of this one, if this is A? It's going to be 0. That's why we had no solution here. If you evaluate it, so let's do it quickly. 0, 1, minus 1, so it's 0, the first one. Then you have here 1 times 1 plus 1 is 2, and this one you will be getting 1, no, minus 1, minus 1, minus 2. So you get 0, 2 plus 0 minus 2, it's 0, the determinant. So if you want to solve any linear system, just make sure that you evaluate the determinant of the coefficients first before you start with the elimination. Because if this determinant is equal to 0, then this tells me that there is no solution, no need to do the calculation. However, if it's not equal to 0, then you will look for a solution. I don't know here. Maybe I will give you a couple of minutes to find out this determinant. So calculate, just to remind you, this is A here. What is this determinant? Is it equal to 0? We only have an issue when the determinant is equal to 0. So I want you just to try to evaluate it, and I want to see some answers there on the chat, just to make sure that you know how to evaluate determinants, which is actually a very essential, let's say, to work with solving linear equations in this system here. So I will just write this determinant down here. Oh, you remember the method, how to solve it, I hope. We did lots of exercises when we talked about you remember when we talked about the cross multiplication or product of vectors? Okay, thank you. So this is equal to -1. And anyway, it's not equal to 0. That means there is a solution for this one. And how to evaluate this solution? You remember we wrote this as, here is the system. So in matrix form, we have the coefficients matrix, we have the X, the capital X, which is the variables, and we have the right-hand side. Now, if you recall the previous example, we were working on multiplying, adding, subtracting the numbers. So that means here X and Y were not affected. X and Y were not affected. And just keeping writing the equation as we did it last time, X and Y and Z, and then carrying this, it's a little bit too complicated. So that's why from now on, we will work on the coefficients matrix and the right-hand side numbers. So these are the values that we need to bring in the echelon form or reduced echelon form. What we are going to do, we are going to create a new matrix where we will combine this matrix and add this column to it. This is what we call the augmented matrix. The augmented matrix is A, and you add to it one column. So this is a 3 by 3 matrix. It will become a 3 by 4 matrix because we add a new column. Okay. This matrix here, we will work on it. So we will construct the augmented matrix for this example, and we will solve it. Okay, so this will result in the 1, 2, 2, 1, 3, 3, 2, 5, 6. And here we add to it just the right-hand side as a column 4, 5, 6. Okay, maybe here we just make a barrier because we are interested in making this one here an upper triangle without this part, but this part, with it, whatever you apply any operation here, it will be actually also applicable for the right-hand side. Don't forget that, because sometimes the students tend to forget this step. Okay. Now, what we are going to do, we are going to work systematically. That means here you have something like, if you just think about it, you have here this diagonal, and your ultimate goal is to have this green framed area with the rest here is 0. So these 3 elements here we need to eliminate. That's why it's called Gauss elimination method in each step, and everyone can start differently, but I will urge you to work systematically. So that means here in each step you will think what I'm going to do next. For instance, here, this is my diagonal here. Below this diagonal, I might start with eliminating this one here, then this one, then that one. Okay. Now here we will do it in 2 ways. We will reduce to echelon form, and then we reduce further to reduced echelon form, and show you what's the difference and how to get the values of the variables there. Okay. And we are going to use the same notation like before. So we start with this matrix. So here we are working in this new matrix with the right-hand side attached to it, and then here 2, 5, 6. Hold on. That was 265, right? 265. 2, 6. 265. Okay, so this is just, that was 65 here. Okay, so now here, the first step, as I told you, I will be just having a circle on the number or the element to be eliminated in the next step. So here, I think everyone can see what is the next step here. The second row will be replaced by, I might subtract the second row from the first row, for instance. Here, R2 minus R1. If I subtract this from that one, I will be getting 0 here. What will I get there? So I keep the first row and the third row constant here. 2, 6, 5, 6, and here. Okay, and now here I will do it on the scratch paper on the side. Let me get one paper here. Okay, let me do it here in this paper. So what will I have? R2 is 1, 3, 3, 5 minus 1 minus 2 minus 2 minus 4. I'm subtracting. So here I got 0, 1, 1, 1. Okay, so I got 0, 1, 1, 1. This is my second row here. Okay, now the next step, I will eliminate this element here. And obviously here, I can't use row number 2 because it's 0 there. Whatever I multiply there, it will not work. So I need to work with row 2, oh, sorry, row 3 and row 1. Okay, so I will replace row 3 minus 2R1 plus R3. Okay, so I will multiply this one with minus 2, add it to this one to eliminate this 2. Okay, so what I will be getting there, I will leave row 3 here, 1, 2, 2, 4, 0, 1, 1, 1. And here, what I will get for row 3. So we said that, don't forget the scratch paper here. So it's negative 2R1. It means negative 2, negative 4, negative 4, negative 8. So I just multiplied the first row with negative 1. Add to it row 3, 2, 6, 5, 6. So this will cancel out as I was planning to do. And this is 2, this is 1, this is 2. Minus this one, of course. Okay, 2, 1, minus 2, and 0. So here I have 0, 2, 1, minus 2. Okay, so to get it into, always think there is here some barriers, because you will think of getting this one as an upper triangle. Okay, so now I'm left with this one here. And this one, obviously, if I subtract it from here, I have different possibilities, but to make sure that this one remains 0, I use row 2 and 3. So I will be replacing row 3 by negative 2R2 plus R3. Okay, and then keeping the other rows unchanged. So 4 here, 0, 1, 1, 1. Now what I get here is, again, it's going to be done on this scratch paper here. So I go to the first, sorry, the second row, multiply it with 2. So I'll be getting 0, 2, 2, sorry, negative 2, negative 2, negative 2. Third row, 0, 2, 1, negative 2. Okay, so here 0, negative 1, negative 4. So 0, 0, negative 1, negative 4. Now, notice that here, if you want only if you want to get only the echelon form, you are there. So this is the echelon form, or the Gauss. And here to find out the value of the or the values of the variables, you need to make more calculations. Okay, let's leave it for now. Here you can solve, but let's continue further to the reduced echelon form. Okay, reduced echelon form, it means here the diagonal you will be having 1, here you have 0. You need to eliminate 3 more elements here. Okay, so let's start with eliminating this one here. Now this one, obviously, if you add it to the next, to the third one, you are there. So here you need, the operation here is R2 will be replaced by adding R2 and R1. Just add R2 and sorry, R2 and R3. 2 and R3. Because here you have 1, you have negative 1. If you add them up, you will be getting 0 anyway. 1, 2, 2, 4. And then here 0, 0, negative 1, negative 4. Now, this one, no need even to do it in scratch paper, because it's actually straightforward. 0, 1, 0. Then you have here negative 3, right? You have negative 3. Okay, now in the next step, we will get rid of this 2 here. Okay, to do that, we just multiply the second one with 2. Sorry, the third one with 2. So 2 times negative 1. So here R1 is replaced by 2R3. Get here, I leave number 1 here. So 0, 1, 0, negative 3. 0, 0, negative 1, negative 4. Okay, let's do it again here in the scratch paper, this one, and see what we get. So 2R3, 0, 0, 2, and 8, negative. And we add to this the first row, 1, 2, 2, and 4. So here you get 1, 2, 0, and negative 4. Double check. 0, 2. Okay. 1, 2, 0, negative 4. Looks good. We have one more element to eliminate, which is this one. Okay, now to eliminate this element here, we will multiply R2 by -2. R2 or R3, this one. No, here, this one. -2. Okay, so the operation we're going to carry on this step is we're replacing R1 by the result of I multiply -2 with R2 and add it to R1. Okay, so here second 0, -3, 0, 0, -1, -4. And here up there I have to do it again on the scratch paper. Let's see what we get here. So -2R2, -2R2 is 0, -2, 0, -6. And here I have 1, 2, 0, -4. Sorry, -2, we said, right? -2R2, here +6. 1, 0, 0, 2. One, 0, 0, 2. 1, 0, 0, 2. Okay, as you see here, this becomes almost the identity with 1 in the diagonal, but we need to fix this -1 here and then multiply it by -1. So here, the last step here remains to just R3, multiply it by -1, R3. So we get it in the right order, 1, 0, 0, 2, 0, 1, 0, -3, 0, 0, 1, and 4 here. Okay, so we are done. This here is the identity we will refer to as I. That means here, bear in mind here that we started with the assumption that this column here, it represents the X coefficients. This one represents the Y, this one represents the Z coefficients. So straightforward here, it follows that X equals 2, Y equals -3, and Z equals to 4 is the solution. So straightforward. This is what we call the reduced echelon form, and this is called the Gauss-Jordan method or algorithm. Okay. So here you have two options. Which one? R1 minus R3. There was here some comment. You're referring to R1 minus R2. Where is it? R1 minus R2.
No, Professor, I was referring to the first step, the first one.
First one here?
Yes, yes, sir.
Something wrong here, or we are?
No, sir. Like in the second row, we just need to get the 0 instead of 1. So you just like replace R2 minus R1, right?
Yeah, which line you are referring to here? 1, 2, 3?
This no, first line, the first line,
First line.
step. Yes.
Yeah.
Can
the
I
first
do this? Yes.
R2
Can
minus
I do this R1 minus R2?
This is R2 the very first step, R2 minus
Yes.
R1.
Yes. Because
R
we ultimately got 0
yes, it's
also here.
R2 minus R1 because you get 0 and then you get 1, 1, 1. Okay, you subtract, you of course you can subtract R1 from R2, but then you will be getting different values, right? Of course,
Yes,
at the end
Professor.
you get the same answer. But this step here, I just subtracted this row from that row. Okay. You got it?
Yes, Professor. Got it.
Yeah, it's this step here. Okay. Okay. Now, as you see here, you have two options. Let's see if we decide to stop here. Of course, we have here the echelon form. You can stop here and solve. Now here, if you stop here at the echelon form, you need to do some calculations. Let's see whether we will be getting the same result. Okay. So I will just write it here. The echelon form, I got 1, 2, 2, 4, 0, 1, 1, 1. And here I got 0, 0, let's say -1 and -4. Okay. Now here, as I told you, you bear in mind this is X, Y, and Z coefficients, and this is the right-hand side. There is an equal sign here with the right-hand side. Okay, now here, if we start from this one, I hope it's clear for everyone. This means negative equals -4. Out of this, we got Z equals to 4. If we go up here, this reads that Y plus Z equals to 1. Out of this, you get Y plus Z equals to 1. Then Y equals 1 minus Z, right? And it's equal to -3. 1 minus 4 is -3. Now here in this step, it reads X plus 2Y plus 2Z equals to 4. Now we know Z is 8. So 4, sorry, this is 8. We know that X, this is -6. And that means here we have X equals to, this is 2, 4 minus 2 is 2, okay? So let's compare the results here. C minus 3, okay? So you see here, this is Y, X2, Y -3, and Z is 4, which is the same like before, okay? So if you are not asked to use a specific method, it's up to you. Either you say, well, I don't want to continue, I can stop here and then solve, or you just go all the way and then evaluate the reduced echelon form, and from there straightforward you can get the values of the variables. Okay, so this is actually the method that we are going, or the systematic method that we will be doing. So let me just summarize it again. This method, either Jordan or Gauss-Jordan. So Gauss elimination. First step, you get you write the equation. So you write the corresponding augmented matrix. Maybe here you just write the system as AX equals to B, matrix form, and then you construct this matrix A with the right-hand side, the coefficients or the constants. Then use the elementary row operations to get to upper triangular. Or if you want to go to the echelon, reduced echelon form, to identity matrix. Okay, so this is summary of the method, and I urge you to work systematically. So you need to think in each step, what do I need to do next, how to achieve that, and also make the calculations on the side using a scratch paper. Otherwise, you might be having some really sometimes very silly errors that will cost you the whole solution. Okay, so this is, be patient and do the calculations on a separate sheet. Very, very, very much recommended. Okay, so let's make some small break here and get back. After we get back to the next section, we will, as I told you, we will introduce the matrices. We will work systematically on matrices, define matrices, and we, as you might expect, matrices have different arithmetic than numbers. It's in a way similar to vectors, but multiplication is a bit more complicated. And to work with solving linear systems, you need to be very proficient in evaluating basic elementary operations of matrices like addition, subtraction, and multiplication, and also evaluating the determinant. As I mentioned, this very often important in this section, which is 3 by 3 or 4 by 4 determinants. I think we did extensively introduce this when we talked about cross multiplication of vectors. Nevertheless, I urge you, if you have problems with that, to make sure that you understand how to apply it. Matrices and determinants are very important here. Okay, so let's take a break and then we will continue.